Okay, let me unfreeze this. Okay, circumference and area. So first, before we plug the numbers in, okay, let's talk about what these words mean. So circumference we did yesterday. So you should know this is like a circle's version of perimeter, okay? So if I were to take this length that goes all the way around and flatten it out one-dimensionally, linearly, what is the distance of that purple line? Okay, that's circumference. Now, area. Area is two-dimensional. Okay, so not only do I want to go this way, I also want to go this way. And it's a lot about little boxes, basically. So 9 centimeters. If I take a little 1 centimeter by 1 centimeter box like this. Okay, and what you're saying in area is how many of these little boxes fit into this circle. So let's see. Ooh, let's make this an infinite cloner. Now I can just keep cloning. How many of these boxes fit in to this circle? Does that make sense? Now, since you are taking boxes and trying to fit them in, you might have sections where it's like, oh, there's a little bit I got to slice off there, right? So you might not have perfect whole numbers, and almost never in circles will you have a perfect whole number, okay? But that's what area is. All right, so you're literally plugging in one number, right? Okay, so let's do the circumference first. I'm going to go like this so I can see my formulas. So big C equals 2 pi, and what is my radius in this scenario? 9, right? 9 centimeters. Now, there's always two different answers. Okay, we're going to have what's called an exact answer, and we're going to have what's called an approximate answer. Okay, my exact answer means I'm going to leave pi in my answer because pi is a very funky decimal that goes on forever, right? And if it's exact, I can't write decimals that go on forever. So I have to leave it like that. So I literally have to just multiply the two numbers around the pi. So what is 2 times 9? 18. So my exact answer would be 18 pi, and this is centimeters because it's one-dimensional, right? When you do the online program, I think they're going to say round to the nearest hundred, so we'll do the same thing in our notes. And I'll go ahead and get out a calculator here. Calculator. Turn it on. We literally type in 18. Okay, use the pi button instead of 3.14 because the pi button has 9 decimal places and way more accurate. It might even go more than that in the calculator. I'm not positive. Okay, but you might have some rounding error if you use 3.14. So then I would say circumference is approximately equal to 56.55 centimeters. Now make sure you round appropriately because probably like any computer program, when you're doing the online stuff, they have to have a fairly exact answer. So if you rounded that last decimal place wrong, left it a 4, you probably would get doctor points. So, okay, so here's the big difference. Exact answer, approximate answer. Okay, now let's do area. Same process. I'll do area over here. Area equals pi times 9 squared. What is 9 squared? Yeah. You can. What's 9 times 9? Anyone?
81.
81. So area equals 81. I leave the pi in there. And now, since we're talking about two-dimensional, instead of centimeters, I would have a centimeter and a centimeter. And when I multiply a centimeter by a centimeter, you get centimeter squared. You can also call that square centimeters. It doesn't matter. It means the same thing. Centimeter square, square centimeters. So here is my exact answer. And now we'll use the calculator to find the approximate answer. Okay, so we'll go 81. And I don't care how you do it. You can literally just type it in the way it looks. Pi times 9 squared. Okay, or you could have done 81 pi. It's going to give you the same answer. And then round appropriately. So your area is approximately 254.47. 254.47 centimeters squared. Okay, so the approximate answer is one that makes sense in the real world, right? Like if you went to Home Depot and you had to get some lumber or something, you wouldn't say, oh, yeah, give me 18 pi. I'd be like, what are you talking about? But you could say, oh, give me about 57 so I could actually go around that circle. You guys remember doing that from previous math classes? Circumference and area? Okay, good. So today's lesson is about sectors and arc length. So I don't know if you need the term over there, except I would definitely call it, maybe title it sector of a circle. I would do a quick sketch of this diagram, and you really need this formula. So make sure you have that down in your notes, please. And we have 6 examples. Okay, this is very closely related to what we just did, right? Which you've done all the way back probably in elementary school. You've done pi r squared probably starting in 4th, 5th, 6th grade, one of those times there. Okay, so this is the same thing. I just don't want to know the area of the whole thing. I want to know the area of just the orange region, okay? So you are finding the area of a piece of the pie. Now you'll notice, look at this, same formula, right? Pi r squared. If I did just the pi r squared, it would be like this whole thing was shaded in. But I don't want to know all of it. I just want to know, we'll highlight in orange here, this many degrees, whatever it is, out of 360, right? So it's a fraction of the circle. All right, everybody got that down? Can I go to the problem? Still writing? Good? Okay. Okay, example number 1. All right, I'm going to write the formula up here. Area equals pi r squared, and then in parentheses, m over 360. Okay, if I look at the instructions, just like we did with the entry, you'll notice it says, give your answer in terms of pi and round your answer to the nearest hundredth. Okay? If it says in terms of pi, that means leave pi in your answer, right? So they want an exact answer and they want an approximate answer where I use a calculator. And all I'm doing is plugging in two numbers and I'm cleaning it up a little bit. The exact answer is harder than the approximate answer. Okay, you guys are really good at typing stuff into calculators. What's the radius in this scenario? Anyone? Radius? 1, right? So 1's going to go in the radius spot. Okay, I don't care about all 360 degrees. I only care about how many degrees? 90. So 90, there, this number. You might also see it out here. Okay, because remember the measure of the arc and the central angle are equal. That goes back to last semester. Is going to go in this spot. Okay, let's clean this thing up a little bit. So A equals pi times 1 squared. What is 1 squared? 1. 1 times 1, right? Let's just change it to 1. Okay, and then in here, if I did 90 over 360 like this, you could just do it like this, but that does reduce. 1/4, right? 90 degrees is a quarter of a piece of pi, so I'll reduce it to 1/4. And then this is my fraction I want. I don't want the whole circle. I want 1/4 of the circle. Now, exact answer. Just multiply those together. 1/4 times 1. 1/4, and I leave pi out of the equation. So when I want an exact answer, I just perform that part. And they always slap it in front of pi. I don't know why. That's just kind of how the way they answer. And this would be meters squared. And then approximate answer. So here's my exact answer. I'll highlight it in purple here. My approximate answer, just use a calculator. Okay, you could type in 1/4 pi. You could type in, or excuse me, 1/4. You could type in 0.25. It doesn't matter. So 1 divided by 4 times pi. Use the pi button. And there's my answer. Okay, not pretty, but accurate. So my approximate answer here is equal to 0. Is it 78 or 79? What does that round to? 79. You guys all know the rules for rounding, right? If it wants 2 decimal places, I look at the next number over. 5 and above, it goes up. 4 and below, it stays the same. So this would be 0.79, and again, meters squared, square meters, however you want to say it. Boom, boom, approximate answer. Okay, on the online program, I'm pretty sure they only want approximate answers. So, all right, let's move to example 2. Yep. Okay, I'm also going to show you, because I'm going to get my calculators. I should have them out by next class. I'll show you some tricks to my calculators to get good fractions, okay? So these numbers are a little bit uglier, right? So area equals pi r squared m over 360. just quick sketches, please. What do you need? This isn't calculator time. You don't need a calculator, right? Are you watching a Netflix movie? Okay. Okay. I'm just plugging in 2 numbers, right? What goes in the R spot? What's the radius in this scenario? 16. What goes in the M spot? 36. So area equals pi times 16 squared times 36 over 360. So that went there. This went here. Okay, you could do the basic math. Like I could figure out what 16 squared is on a calculator. It's 256. I could also reduce this. This reduces to 1/10, right? So again, the exact answer is the hardest part because you need to do this math, right? And leave pi out of the answer. So again, if I did all the work, and I'll show you how to cheat and use the calculator here a little bit. Okay. This would turn into 256. This would reduce to 1/10. If I were to multiply those together, I still got this pi here. Now I got 256 over 10. And then I would have to reduce that number. And that reduces to 2 goes into both of those numbers. And so my final answer here would be, and they always slap it in front of pi, 1/28 pi, and this is inches squared, square inches, however you want to say it. So you'll notice no decimals, okay? So when they do exact answers, they want reduced fractions, and that's the hardest part about this, okay? Now, let me show you how you could have cheated and used my calculator to get a reduced fraction real quick, instead of doing all that extra math. Okay, I can literally just do what I circled in blue over there in my calculator, right? So turn on 16 squared, okay, in parentheses, 36 divided by 360. And I get that decimal, okay? But I want to change that decimal into a fraction, a reduced fraction. You guys remember math frac? So when you get to use these calculators, math, frac, and boom. Okay, so that's a little easier than going through that process and making minor errors on the reducing fractions part, okay? All right, exact answer is that. What about my approximate answer? So I'm going to take that last answer and then I'm going to multiply it by pi, and I get this. So here's my exact answer. 128 times pi. Here's my approximate answer, 80.42. And this is inches squared. Okay, let's do this next one where I don't do all this. I'm just going to go from here to here. Try this one without me. Give it a shot. See what you get. You will need a calculator, especially for the approximation. Okay, let's see if you got what I got. So area equals pi. I'm going to go ahead and square my radius. I'm going to plug in something here in the numerator. Okay, so my radius goes in the square part, so I'm going to put a 9 right here. And I don't care about all 360, I only care about 120 degrees out of that 360. Okay, so I'm taking a piece of the pi. Now, I'm going to let the calculator do the tedious work for me, okay? If I want an exact answer, it means I am going to leave pi out of my calculations. So on my calculator here, I would say 9 squared, okay, in parentheses, 120 divided by 360. Now again, you could reduce that to 1/3, right? But you don't have to. The calculator will do the math for you. Look at that one. Sometimes it'll turn into nice clean whole numbers. So my exact answer is 27 pi. And this is in inches again. Inches squared, square inches, however you want to say it. So there's my exact answer. And then my approximate answer is 84.82. And we'll highlight that one in maroon orange or maroon red here. All right, what do you think? Not too bad? Okay, on the online program, you don't have to do exact answers, I believe. I think it's all approximate. Okay, so plug the thing in the right spot of the formula, hit enter, make sure you round appropriately, get 5 in a row, and you can move on. All right, this one's a little more challenging. Quick sketch. No radius given. But if you look in the instructions, it gives you the area, and you are looking for the radius. So while you draw your picture, I am going to write the formula again. So big area of the sector, pi r squared m over 360 . Okay, I can actually put something over here in this A spot. What goes in the A spot? What is the area? 16 pi, right? Don't forget the pi. 16 pi. So they give me the area up there. I'll fill it in here. Pi, I'm going to leave r as my variable. And then what would go in this orange spot right here? 90. Let's just reduce that right now. 1/4. Good. So 1/4. Okay, so by plugging in 90 there, I get this. Okay, we need to solve for r, so we need to do some basic algebra steps. I probably would get rid of that fraction. That's an easy way to start. I don't like having that 4 down there in the denominator. Life's a lot better without fractions, right? I'm okay with the 1 there, but I don't like this dividing by 4. What's the opposite of dividing by 4? Multiplying. So would you agree if I did times 4 here, these would cross cancel? And then I balance out my equations. Whatever I do to one side, I do to the other. Okay, 16 times 4 is 64. So So now I get 64 pi equals pi r squared. I guess you could put that 1 to the right, but we don't need it, right? Okay, my goal is to get r by itself. It's pi, remember, is a number, and that number pi is being multiplied by r squared. What's the opposite of multiplication?
Divide.
Divide. And just like we had last class, look how convenient this is. When I balance out my equations, pi goes away on this side, pi goes away on that side. I get 64 equals r squared. And we've done this quite a few times when we did the Pythagorean theorem, right? What? Good. The opposite of square something is square rooting. If I square root this side, it basically goes away when I balance out my equations. What is the square root of 64?
8.
8. Radius equals 8. So same math, a little bit more work. Just got to go backwards. Okay, next set of notes. Two examples to go. Arc length. Okay, so arc length relates to circumference. Circumference is the distance around a circle, right? Arc length means I don't want to know all the way around. I just want to know a portion. And in this scenario, I would want to know what is the length between A and B. If I were to line it out straight, so this is linear, one dimension, right, instead of two. But you'll notice it's almost identical. This is the formula for circumference. And again, I don't care about the whole thing. I just care about a piece of the pie. Now, oftentimes they did draw it going back to the center, but you don't need to have it going back to the center sometimes. So I'm going to scroll down to example 5 here. So what I mean by that is, like, if you look at this picture, I don't really need the radii there, do I? Sometimes it'll be in the problem, sometimes it won't. Okay, they give me that the measure of this arc length is 90 degrees out of the 360. And on the other one, they used a big A for area. This one, they used a big L for length, arc length. So big L equals 2 pi. What should I put in this radius spot here? What is the radius of this problem? 10, good. So here's my radius. And then I'm going to use a fraction here. Always over 360. And how many degrees out of 360 do I care about? 90. So 90 goes here. Now, this is a little bit weird when I do my calculations.
Hi, may we have Julianne Brenner to the student office briefly, please?
You got it.
Thank you.
You might want to take your stuff because I don't know, 10 minutes might not be enough time. Okay, so this is a little bit weird because you notice how they have the 2 on the left of the pie here? So again, when I do my calculations for an exact answer, I need to do this 2 and all of this stuff. Okay, skip pi out of the equation. So what is 2 times 10? So now I have 20 times, and this reduces to 1/4, right? And pi, I'm going to throw over here on the right. And what is 1/4 of 20, or what is 20 divided by 4? 5. So my exact answer is 5 pi, and this is in feet. And since it is one-dimensional, I don't need to square. What is the distance if I were to lay it out flat? And now a calculator. So exact answer, 5 pi. Calculator on 5-second pi, we get 15.71. Approximate answer. All right, one more of those and let's call it a day. And again, the answers that I gave, the problems I throw on here, okay, I purposely chose ones that didn't have the radius going to the points. But again, you might see ones that look like this and they give you a radius like that. Okay, I left it off just because then you get confused. Is it sector area or is it arc length? Okay, I'm going to go ahead and put the formula up here. L equals, since it's arc length, 2 pi r m over 360. And then I'm literally just going to plug in two numbers. And I'm going to let the calculator do a little work for me on this one, okay? So what is the radius in this scenario? What goes right here? Anyone? 6, good. How many degrees do I care about out of the 360? 40. So if I wrote it out, L equals 2 pi times 6. Even on calculators, I don't even need to put the multiplication. If the numbers are right next to the word pi, the calculator will know to multiply. And I care about 40 out of 360. Now, so we don't make tedious errors in reducing fractions. Let's let the calculator figure out our fraction for us. But again, I don't want pi in my calculations for my exact answer. So I need to include this 2 and all of this stuff. Okay, it's almost like I'm taking this term pi out of the equation and moving it over here to the right. So in my calculator, okay, I'm going to do 2 times 6 times 40 divided by 360, enter, and I get that. Okay, this is the biggest mistake. Don't put, 1.33 pi. I don't want decimals. Math, frac, 4/3. So L equals 4/3. I leave pi in the equation. And we are in meters. Okay, don't square it because it is a one-dimensional distance. Okay, now do 4 divided by 3 times the pi button, and we get 4.19. And our approximate answer. And that is it for notes.